the same variable, oops, bless you, the same variable raised to the same power or exponent, right? So if one has a little 2, the other one has a little 2. So what we're going to do, practice identifying some like terms, practice combining them. How do you do that? What's the point? Well, we're going to have to Jaden, there is none, but we're going to have multi-step equations, and you're going to have to sometimes combine like terms in order to solve. So circle the like terms in the following examples. We have x, 4, and 2x. Asia. X and 2x, right? Why not the 4? There's no x on it, right? So my like terms, and that's all we're doing with these, just circle them, okay? It's just x and 2x. Good, so then part B, we have 6, 3x, 2x, and y. Where are some like terms in that one? Dallas? 3x and 2x, right? The 6 is no good because there's no x on it. And then isn't y a completely different variable? Yeah. All right, now we have x squared, x, and 3x squared, and y. What would go together in this one? This one's a little trickier. Asia? X squared would go with 3x squared. Why not the regular x? It doesn't have an exponent. Don't the other ones have the little 2 on them? Does the other x have a little 2? So they're not the same. And then the other one's a completely different letter. All right, and then part D, we have 7, 10, 2x, y, and 3. I see 3 different like terms here, actually. Jaden? Yeah, the basic numbers, right? Can you combine numbers with each other? Yeah, not normally. So those are like terms. The 2x, that's the only x there. It doesn't match with anybody. And the y is the only y there. Good, Mason. So that one also can't combine with anybody. Are we kind of remembering what a like term is? Things that look the same. Okay, so an x goes with an x, Alex, a y goes with a y, things like that. All right, so what we're going to do now is we're actually going to simplify by combining like terms. Now, when your directions say simplify, do simplify and solve mean the same thing? No. Simplify means to simply combine what you can, reduce fractions, distribute maybe, things like that. Solve, you have to have what symbol in order to solve something? An equal sign. Do any of these first couple examples have equal signs? So there are no equal signs in this one. That means I don't want to know what x equals. I just want you to combine what can be combined, right? Get this in as few terms as possible. So we're going to just practice first identifying our like terms. You can circle them. If you're someone who likes highlighting, maybe highlight it, do what you like, okay? And then we're going to combine them. So where do you guys see some like terms in number 1? Dallas? Yeah, 6 and 4. Asia, where else? X and X. Exactly. Okay. So we've identified our like terms. Writing this down, Corey? Now we are going to combine it. Okay. So it actually doesn't matter which ones you combine first. Do what you feel most comfortable with. I'm just going to, for now, go from left to right. So if you have a 6 minus 4, how can you combine 6 minus 4? Subtract it. What's 6 minus 4? 2. Okay, so that part is going to be 2. Right? And then x plus x. Now here's where we maybe need to review a little bit. Okay. X plus x. It'd be what? But is there only one of them? Dallas? That'd be if you multiplied them. The little 2, that's when we multiply. It'd be 2x, yeah. Think of it if you have an x, right? Physically, if you're holding an x and you're holding another x, how many x's do you have all together? 2. So just treat them kind of like they're normal numbers. So that would be, don't forget your plus sign, and then 2x. Okay, so x plus x is 2x. Good, Mason. And then that's it. That's all we got to do for that one. We've combined them. That's all as far as we can get. All right, so look at number 2. Where do we see some like terms in number 2? Asia. Okay, we got a 3x and a 2x. Where else? Yeah, we got a 3 and a -1. Okay. So now let's combine what can be combined. So now you have 3 x's. Add that to 2 x's. How many do you have all together? 5 x's. Good. Because right here, this first thing, doesn't this say 3x? That means you have 3 x's. Does that make sense? Okay. So that would be 5x. And now your numbers, we have a 3 and a -1. So what's 3 minus 1? 2. So plus 2. Good. I'm going to start calling on people online too, so make sure we're paying attention. Are there any questions so far? Okay. Yes, Lynn. Sure. Yeah, one. If you go down to the main office, they can point you in the right direction. Okay. I'm confused. It's the sign you're supposed to. So Mason, use here. Wait 1 second. So Lynn. Ooh. Depends on the day. Well, it depends how many kids have made her mad early before you get there. It's early. She'll be nice. There you go, Lynn. Do you know where the main office is? Oh, that's okay. Do you know where the main office is from here? So go to the big set of library stairs, walk down, and then when you get to the bottom, take a right, and then just follow that down until you get to the main office, and the lady at the front desk there will tell you where to go. Okay? All right. Okay, so Mason, so the sign you use depends on the numbers you have here. So see how this 3x, it's positive. This 2x is positive, so you add. This 3 is positive. This 1 is negative, so you subtract. Does that help, Mason? Okay, cool. All right, number 3. Identify some like terms for me. Jaden. Okay, and the 2x would go with what other thing here? Yeah, that -x, right? Good. Y with the other, yeah, good. The positive y with the positive 3y. You're welcome, Mason. And does the -4 have any buddies? Any just plain old numbers in this? No, there's none left. Okay. So now let's combine what we got. So we have a 2x minus x, right? If you have 2 of something and you take 1 away, how many's left? Just 1. So you can either write 1x or just write x. It doesn't matter which way you write that. Some people like to put the 1 in front. You don't have to. It's up to you. Okay. Now let's look at the y's. We have a y plus 3y. So what do you think that's going to give you all together? 4y. Good. So plus 4y. And then did that -4 have anybody to combine with? No. So you can just bring him down with you, -4. That's fine for now. We'll talk about what's like technically the proper order to write them in, but that's a different section, so don't stress about that yet. Good. Good question, Dallas. All right, Bailey, you good back there? You look like you're zoning out. Okay. Uh-oh, do you need a new thing to write with? You can grab a pencil from my desk. All right, number 4. Somebody online. I've heard from the people in class, somebody online. Where do we have some like terms in number 4? You're here. I've already heard from you once. How about Hannah? Where do you see some like terms in number 4, Hannah? Yeah, both the 2x's. Now the x squared, is that the same or is that a little different? That one's actually a little different. You have to have the same exponent. So that one actually doesn't have any buddies. It's just going to stay by itself. Okay, good job, Hannah. Jake Newcomb, where else do you see some like terms? Oh no, what happened here? Do we have you there, Jake? Not sure, or did you chat me? Okay. Owen chatted 2x and 2x, good, Owen. And then Kaysen, good. 5 and -2 would also work. Okay, so now let's combine what we got. So, Jake Sanders, what would you get with 2x plus 2x? 4x, exactly. 2x plus 2x is going to give you 4x. What's, Jesse, what's 5 minus 1 going to give you? 4, good. And then can we do anything with that -x squared, guys? Did you see anybody else that has a squared on it? No, so just bring it down with you. I'm just going to bring down the -x squared. Now, if you wrote that in a little bit different order, but as long as everybody has the same sign in front of it, that's fine. Okay, good. I just tend to bring down what we haven't dealt with last. Questions about that? Or are you awake? You sure? I don't think I've seen you pick up a pencil yet. You got this written down? Okay. I've seen you scribble all over your paper and play with your broken pen. Grab a pencil or something. Do you have something else to write with? Okay. Killing me. All right. Distributive property. Have you guys heard of distributing before? You have at some point, even if you don't remember. Most of the time when I ask, I know that at some point it's happened. So distributive property, remember that means multiply everything in the parentheses by the number outside. So if you have something like 2 times 3 plus 4, what you do is you multiply that 2 by everybody inside. And there's more than one correct order to do this in. But here, what's 2 times 3? 6. What's 2 times 4? 12. And then what's 6 plus 12? 18. Yeah, good, Asia. Not 81. You're just saying stuff. It doesn't mean it's... So does that mean if I gave you, would you rather have $15 or $51? It's the same numbers. Yeah, but it's the same numbers, Jaden. All right, number 1. So we're going to practice distributing. Now in these, there's some variables, right? Okay, so we're going to have to talk about what happens when you multiply a number and a variable. A letter. So in number 1, you got 3 times x. 3 times x. Any ideas of how you can write 3 times x, Dallas? It's just 3x. Pay attention, Jade. You're just, I don't know what you're doing over there. Losing your mind. Then write this down, man. I don't know what to tell you. Life is boring. It's not going to get much better right now. Sorry, bud. All right, so 3 times x is just 3x, okay? If there was a number in the front, you would multiply it. So for example, 3 times 2x, 3 times 2 is 6, right? So it'd be 6x. All right, and then what's 3 times -2? Nope, 3 times -2. -6. And that's it. That's all you got to do. Okay, yeah, good, Owen. All right, let's look at number 2. We got 2 times 5. Mason, what's 2 times 5? What kind of a 10 though? Yeah, okay, good. Negative 10. Don't forget your negative. And then 2 times negative 2 times x. First of all, a negative times a positive is a what? A negative times a positive is a, Jaden, one more time. A negative times a positive is a, well, you kept saying positive. It should be negative. A negative times a positive is a negative. So 2 times x then will just give you 2x. Okay? And then you're done with that one. That's all you got to do. Did you write it down? Jaden, I'm worried about you today, bud. All right. Number 3. You got negative 3 times x plus 4. So negative 3 times x. You got one negative and one positive. What's a negative times a positive? A negative. So that's going to give you negative 3x. And negative 3 times 4 is going to give you, negative times a positive is a negative. You're adding. We're multiplying here. We're multiplying. Yeah, when you distribute, you're multiplying. So 3 times 4, right, would give you 12. In this situation, right, negative 12. Okay, good. Now, number 4, what looks different about number 4? Yeah, there's more numbers in the parentheses, right? Now think about our order of operations. Can we simplify in our parentheses first?
Yes.
Yes. Where do you see some like terms inside your parentheses? Yeah, the 4 and the negative 2. So let's rewrite this. Let's simplify a little bit. I'm just going to bring my 3 with me. We haven't done anything with it yet. And then what's 4 minus 2? Positive 2. So 4 minus 2 is 2. And then bring your plus x with you. Good. Okay. So now let's distribute. Corey, what's 3 times 2 going to give us? 6. And then Bailey, what's 3 times x going to give us? 3x. So you'll have 6 plus 3x. Good. No, we're done. There's no equal sign on this one. No equal sign on this one. All right. Number 5, there's even more going on, isn't there? Whoa. So let's see what we can combine before we get started. Let's look in those parentheses first. Alex, do you see any like terms in your parentheses? Yeah. And the x, yeah. 4x and that other x, right? Good. So let's now, there's also a 6x on the outside, but that's not in your parentheses, right? So we can't mix those together yet. We got to focus inside our parentheses first. So let's just copy down what we're not changing yet. We're not messing with this negative sign yet, so just bring it with you. And then, Jaden, what's 4x minus x going to give you? If you have 4 of them and you take one away. 3. So that's going to give you 3x. We're not messing with the 2 yet. Plus 6x minus 2. We haven't messed with any of that yet. I'm confused, guys. There's a negative. Thank you. Help me, Jaden. There's a negative outside of my parentheses. What in the good world am I supposed to do with that? Oh, no. Actually, you can just recycle and anybody know what to do with that negative, either in the class or on the internet? What would we do with that negative that's outside our parentheses? What does it mean? Good, yeah, that makes sense, Mason. So technically, it's a negative sign, but isn't it in front of parentheses? And parentheses technically mean multiply. So this is actually what number in front of your parentheses? A negative, yeah, a -1. It's a -1, yep. This is technically saying there's a -1 on the outside. That's okay. So we're going to distribute our -1. Now what happens if we took -1 times 3x? It'd be -3x, good. And then what's going to happen if you take -1 times 2? -2. And then just drop down your 6x and your -2. That's good, Mason. All right, so now where do we see some like terms? Owen, where do you see some like terms in number 5 now? You there, Owen? Good, -3x and 6x. Good, -3x and 6x. Nick, where else are there some like terms? Yeah, -2 and -2. Good. So let's combine those. Now be careful when you're adding and subtracting here. Should we ever guess? What are we all allowed to use in this class? A calculator. You're allowed to use a calculator. So if you don't know what -3 plus 6 is, plug it into your calculator. So what is -3x plus 6x going to give us, Asia? Not 8. No, you might be looking at the 2's. -3 plus 6. Good, Mason. Yes, it's 3x. I think you might have looked at the 2 with the 6. We took -3x plus 6. Well, grab a calculator. I'm not insane. If you think I'm insane, then you guys still grab it. Guys, go grab a calculator. If you don't have a calculator out, go grab one. Apparently you do, because you've been telling me weird numbers all day. Also, go wash your hands. You're about to get ink all over my desk. Go wash your hands. There's ink everywhere, man. Are you even doing anything you're supposed to be doing today? Oh my. Just make sure you put them back in the box when you're done with them, guys. Okay. A lot of us are guessing. Okay. So in your calculator, Alex, if you do -3 plus 6, so the little negative, use the one at the bottom in the parentheses. Do you see that down there? So you hit that, then hit your 3. So -3 plus 6, what did it give you? Yeah. Do you see what's happening now? Okay. So now we got -2 minus 2. Lynn, what's -2 minus 2 going to give us? No, we got -2 take away 2. So remember, always add same signs. What's 2 plus 2? 4, but you were already at negative, right? And you went down more, so it'd be -4. Good. Good. Okay. And then last one of these, and then we'll take a little break, and then we're going to solve. Okay. So now, again, there's a lot going on this one, right? So let's take a look at it a little bit at a time. So if you look just inside your parentheses, can we go ahead and combine an x with a 3 yet? No, not yet. Now look outside. I see an x squared. I see a -5x. I see a 3. None of those are like terms yet, though. So we can't combine anything yet. What could we do, though? Dallas. What could we do with that? Yeah, distributive property. Very good. Yeah, we're going to distribute our 4 here. Yes, Lynn. Yeah. Yeah, I'll show you mine 2 in a second. So what's 4 times x going to give us? 4. Yeah, no, for sure. Yeah, I'll have it all posted after class, Len, so you should be able to look at it in SRT. So 4 times x is 4x. What's 4 times -3? -12, good. And then we haven't done anything with our x squared, our -5x, or our 3 yet. Oops. So we're just going to bring that down. Okay, good. Aiden, where do you see some like terms in number 6? Any ideas, Aiden? All right, Annalise, where do you see some like terms, Annalise? Very good, yeah. 4x would go with this -5x, good. Kaysen, where else do you see some like terms? Yep, the 12 and the 3. -12 with the 3. And then the x squared, what are you doing? Just put it down. There you go. Okay, so the x squared is just by itself. There's no one else to combine with the x squared. So we have 4x minus 5x. Corey, what's 4x minus 5x going to give us? Well, if you have, I'm sorry? You're so close. There's just one little thing you're missing. If you take 4, take away 5, -x. And you can either write it -1x, Corey, or just -x. It's up to you. Either way. So -1x or -x. -12 plus 3. Jaden, what's -12 plus 3 going to give us? What kind? -9? Yeah, and you could put a 1 in front of it if you want, Len. It means the same thing. And then the x squared had nobody to combine with, so we're just going to drop that down. Okay? Okay. So some equations. So we didn't have those calculators out. Better get them out now. Have you guys ever heard of, and I've actually seen a few people do it on their work so far. I like to call it the 2-column method, where you draw a line from your equal sign and you organize your information in 2 different columns. I saw a few people do it. Maybe it was like Jesse and one other person. I think I saw do this on your homework. I'm going to show you this method because I think it really helps with organization. So when we're solving an equation, we're trying to get our variable by itself, right? So what that means is we want all our variables on one side, so all your letters on one side, all your numbers on the other. So if you look at number 1, we have 2n plus 3 equals 9. We need all our letters on one side, all our numbers on the other. So what I'm going to do is I'm going to draw myself a little vertical line going through your equal sign, and I'd like you to do the same. Good. Well, and a lot of people, I noticed when I was looking through your guys' work, some of you already do this. It's just a really nice way to organize your work. If you know how to do it without it and you're doing it well, that's fine. But if you're making a lot of mistakes, I'm going to make you switch over to this way. So what I like to do is I like to get all my letters on the left, all my numbers on the right. So 2m, is that going to be a letter or a number? That's a letter, right? It has an n in it. So we're going to leave 2n on the left. And then don't forget your equal sign under your other equal sign. Now we got a 3. Is a 3 a letter or a number? A 3? Is a 3 a letter or a number? It's a number. Okay. So it needs to move over, right? It's not on the correct side right now. Now, when you move something to the other side of the equal sign, does anyone, yeah, you kind of got to do the same. It needs to balance out, right? So if I take a positive 3 and I move it to the other side, does anyone know what's going to happen to it? it's going to become a -3. We're going to move it over because technically, what's the opposite of adding? Subtraction, right? So when I move it over, it's going to become the opposite. Now, this is just one way to organize it. I'll show you another way in a second. So I've used the 10, I've used the 3. What about the 9? Is the 9 good where it is? Yeah, the 9 is good where it is. It's already on the right, so I'm just going to drop down a +9. Good. Now, what's nice about this strategy is I can now just combine my like terms. Take a look at the left. 2n is over there by itself, right? So it's good for now. I'm just going to leave it as 2n equals. Now we have a -3 plus 9. Don't guess. What's -3 plus 9? Nope. 6. 6. When one's negative and one's positive, Asia, think of it like subtraction. And then you have more positive numbers here, so it'll be a +6. Okay? And now we just need to get our variable all by itself. Any ideas what we need to do with that too? Jaden? Divide. We're now going to divide both sides by 2. And we're going to get, what's 6 divided by 2? 3. Oh, sorry. You can do it in more than one way, Lynn. So if you have a different strategy you like, do that. I'm just going to show you guys 2 different ways, okay? And then pick which way you like. If you do it wrong the other way, I'm going to make you do it this way, though. So number 2, then, let me show you just our traditional strategy, right? We use opposite operations. So we have 3n. Jaden, please stop pounding on your desk. We have 3n minus 1 equals 11. So I want to get my variable all by itself, right? Okay. So that means I got to get rid of the 3. I got to get rid of the -1. Asia. Correct, right? The opposite of subtracting. And now this way, I'm not doing my 2-column method. I'm just showing you the traditional way, just so you know what your options are. And then for the rest of them, I'm going to do the 2-column method because I think it helps people organize it. I just want to show people this is okay too. I think it is as well. You don't have to guess about what to do first. You just organize it, right? So add your 1 over. That's going to give you 3n equals 12. And then what do you do with your 3? Divide it. Now this way might seem shorter. It's just a little easier to make mistakes using that method, okay? I just want to show you that this is an okay strategy too. Just moving a number or variable to the right. So Mason, anytime you move it to either side, right or left, it's going to become the opposite. So if you move a positive over, it's going to become negative. And if you move a negative over, it's going to become positive. It doesn't really matter which direction, just if you move it to either side, okay? Make it the opposite. No, I would always put your numbers on the left and your variables on the left and your numbers on the right. Because it's what's going to make more sense to your brain. I know this because I've taught math for 7 years. So, all right, number 4. So we're going to use our 2-column method. Let's organize this, okay? So I'm going to put my column down through my equal sign. We want all of our numbers, or I'm sorry, all of our letters are variables on the left, okay? So we want variables over here, and we want numbers over here, okay? So let's just go in order. -2x, variable or number? Variable, so keep it or move it? Keep it. We're gonna keep our -2x there, and I'm gonna cross it out because we're done with it right now. Corey, stay alive. -3x. It's a variable, it's good where it is. We're gonna leave it right there. Except my pen is having a connection. Why does this always happen to me? I don't know what's happening. Hold, please. I don't know, it doesn't like me right now. Let me try my other one. I'm not sure. minus. Why is this doing this? I don't know what's happening. It is going broken.
Your pens are going, wow.
It like doesn't want me to write anything right there for some reason. I don't know why. Is the screen dirty? Huh? I wonder if the. I don't know. Let's see. Yeah, it like doesn't want me to write right there. Anywhere else is fine. I don't know. I got it to kind of work, so we'll just leave it like that for now. Okay. So now the 7. Is the 7 good or does it need to move? It needs to move and become, it's right now it's positive, so we're gonna move it and make it a -7. And then the -3, is that good where it is or does it need to move? It's good, it's already on that side, right? So just leave it as a -3. So now let's combine our like terms. -2x minus 3x is going to give you what? What's -2 minus 3? Check it in your calculator. What's -2 minus 3? Jaden? -5. So that's -5x equals, and then yes, Asia, what's your question? You're probably using the wrong negative. I will show you in just a second. I will, give me 1 second, I'll come show you. -7 minus 3 is going to give you -10. And then last thing, we need to divide both sides by what? -5. My goal is to make things, yeah, pretty much. Thank you. A negative divided by a negative is a, and 10 divided by 5 is incorrect. It's 2. You subtracted. That's okay. All right. Asia, let me come see what you guys are doing.
Oh, wait, I can read number 5.
Well, because so there's a difference between a negative sign and a negative just means the
I need help.
number is negative, subtract means literally take away. Okay, so like this one, if you wanted to do, so technically this should be a negative 10 to fix that, make that a negative, right? Now both of the values of these are negative, right? So what you would do is you put -10 divide, and you wouldn't use your subtraction sign, because you're not subtracting, it just has a negative value, so divide by -5. Okay? It'll take some getting used to. You understand?
I need help.
Okay.
I got to hear another stuff.
Okay, you need to now, so you move the 8 over, so what's -16 plus 8?
8.
-8. You figure out your C here, so that should be 4C, put your C, equals, and then -8. The only ones that don't.
And that's the answer.
Yeah, for now. No, you gotta divide now, Jaden. Okay, so, let's see where we're at so far with number 5. So, Asia, 6C, did you leave it there or did you move it? You leave it, good. 1 second, I'll show you. Corey, the -8, should we leave it there or should we move it over? Move it over and switch it from a negative to a Positive. Anytime you move it, make sure you make it the opposite sign. Good. Alex, negative 2c. Leave it there or move it over? Leave it there. Good. And then Dallas, the negative 16, leave it there or move it over? Yeah, leave it there because it's already on my number side. Good. And that looks like a Z. It's a 2. Okay. So, Bailey, 4C minus 2C is going to give you what? I'm sorry, 6C. I already told you what it is. 6C minus 2C is going to give you what? 4C. I do that a lot, actually. You guys will notice that. Lynn, 8 minus 16 is going to give you? Negative 8. Good. Well, now you know. So divide by 4 and you should get negative 2. Good job. Oh, okay. Yeah, just be careful with your signs. Jaden, we're doing a lot of hitting and slapping and weird noises today. And all right, so part 6. We're going to try to get through as many of these as we can, but we're not going to stress about it because we're doing the same thing next class. We're just doing more of these because this is, people sometimes, you're either really, really good at this, you either remember it or you need to practice it. Regardless, it's good practice because we solve a lot of equations all year, okay? So number 6, put your little column. We want our numbers, right? We want our letters over here. Oh no, what am I doing, guys? We want our letters over here. We want our numbers over here. So 36. Nick, the 36, should we leave it or should we move it to the number side? Well, does 36 have a letter on it? No, so we want to move it and change it from a positive to a what? A negative, good. So move the 36 over, make it a negative because there's no number on it, okay? Now we're over on our number side. So Jesse, 13N, should 13N stay there or should we move it over to the letter side? What do you think, Jesse? I don't know if Jesse can hear me. Jake Sanders, what do you think? Should we move the 13N over or should we leave it there? Good, and make it what kind of a 13N, Jake? Well, if it was 13N on the right, what kind of 13N should you make it when you move it to the left? Yeah, negative. Anytime you move it, doesn't matter which side, right? Just make it the opposite. So good. So move your 13N over, make it negative. And then Mason, what about for the negative 4N? What do you think, Mason, for the negative 4N? Should I move it? Should I leave it there? What kind of 4N? All right, Mason might be stuck. Lynn, what do you think? The negative 4N. Are we going to leave it there or are we going to move it? We're going to move it and change it from a negative to a positive. Okay. Now let's combine our like terms. Owen, what's negative 13N plus 4N? Sorry, my people at home are asleep. Jaden, what's negative 13N plus 4N? Okay, there we go. Owen's back. Owen's alive. We got negative 9N equals negative 36. Bailey, do what to both sides now? Yeah. Do we want to add, subtract, multiply, divide? What do we want to do with that -9, Bailey? Yep. Divide both sides by -9. And a negative divided by a negative is a positive, and 36 divided by 9 is 4. Good. Let's do one more, and then I'm going to show you guys your homework. I know we're not going to get to the last two. That's okay. I want to show you guys what your homework is, show you where to find it, okay? And we're doing more of this tomorrow, so it's not a big deal. Number 7. Let's get our 2 columns. Good, Kason. All right. So let's decide who's going to move, who's going to stay. Annalise, 4M, is that going to stay, or do we need to move it over? Letters are going to stay. Good. 4M is a letter. It is staying. Corey, what about 5? Yep. Very good. Move it to the other side. Make it a negative. So move a -5 over. -3M. Jake Newcomb, what do we think with a -3M? Jake Newcomb. All right. Kason, what do you think with a -3M? And Kason's there. Kason's probably just thinking, you know. Don't move it. Correct, Kason, don't move it. We're going to leave the 3M where it is. And then the 10's already on the other side. So we're going to leave the 10 there as well. Good? 4M minus 3M. Dallas, what's 4M minus 3M? 4 minus 3? That's okay. Because you were thinking 5's on the other side. I know what you're thinking. Well, it's 1M or just M. Good. You can leave the 1 if you want. And then Dallas, what's -5 plus 10? That's where the 5 was coming from. So that's just M equals 5. Okay, good. We're not going to do the last two today. We've been talking for too long.